history of our Earth. I'm going to go 46 billion years away.
"46 billion years ago, the Earth formed.
3.9 billion years ago, the oldest rocks formed.
4 billion years ago, life on Earth began.
Pardon? What began?
Life on Earth.
Animal hard parts appear.
At 350 million years ago,
Insects appear.
insects appeared.
At 300 million years ago, coal started to appear.
200 million years ago, dinosaurs appeared.
9 million years ago,
Landmass.
landmass broke into continent.
30 million years ago, plants and flowering appeared.
5 million years ago, dinosaurs became extinct.
60 million years ago, plants and birds appeared. 100,000 years ago, human appeared. 40,000 years ago, modern humans appeared.
6,000 years ago, recorded history begins.
2,000 years ago, the modern Christian calendar appeared.
Years ago, the
Industrial.
Industrial Revolution began.
Industrial revolution started to pollute our world. We need to be careful to protect our world.
What are you gonna do about it? We're going to talk about volcanoes and how they erupt.
A volcano is an opening in the earth through which magma, gases, solid rock, fragments, poisonous fumes, and ashes can be discharged. There are about 500 active volcanoes in the world today.
Underneath volcanoes in the Earth's mantle, there are pockets of magma. As heat and pressure build up in these magma chambers, the gases expand.
The magma is forced up the volcanoes and out the crater. The opening at the top of the volcano. The eruption ends when all the pressure has been relieved. As the lava cools, it solidifies into rock. Igneous rocks such as obsidian, pumice, and basalt result from cooled lava.
Sometimes magma doesn't reach the Earth's crust. Instead, it forces into or beneath areas of rock.
We are going to demonstrate how a volcano erupts.
This volcano is made out of paper mache, a plastic bottle, and acrylic paint. First, we're going to start out with 4 tablespoons of baking soda.
Then we're going to do 4 tablespoons of just dish soap. And then 3 to 4 drops of red food coloring.
Finally, we're going to use about a cup of vinegar. And there's your explosion.
Thanks for watching!
Hello, my name is Max, and today I will be talking about wind erosion. Erosion is the wearing away and movement of rocks and soil by natural forces. When rocks erode, they break apart and become smaller and jagged. Eventually, they become smooth. When small bits of rock are pressed together for many, many years, they can form a layer of sedimentary rock. Weathering, exposure to air, wind, water, and temperature shifts is a major cause of erosion. For example, sand particles blown by the wind against solid rock can act the same way that sandpaper rubbing against wood. Windstorms can swirl away huge amounts of dry soil in a matter of minutes. Here we have a pile of dry sand. Now Mia is going to blow into the pile with the straw to create wind. You can make holes in the pile of sand. This is a model of wind erosion. Now for our next project. Divide both sides of several popsicle sticks into 1 centimeter thick bands. Use crayons to color each band a different color. All bands at the same level should be the same color. Example, all top bands are red. Now for our second part, Blair will be talking about water erosion.
Hello, my name is Sophia. Today I will be talking to you about water erosion. Glaciers. Moving ice fields whose huge masses of ice can survive even the hottest summer cause considerable erosion as they scrape rocks along the ground for long distances. Water can cause erosion when it trickles into cracks in rocks, freezes, expands, and then refreezes, contracts, and trickles deeper into cracks, thus forcing the cracks to open wider. Water in motion is one of the most powerful causes of erosion. Rivers are formed by running water. Riverbanks are eroded away by running water. Gullies are formed in fields when heavy rains wash away soil, and water in motion can even cause landslides and detach soiled blocks of rock.
Pack down damp, non-wet sand and to build a mountain. On one side of a large pan, put a book under the pan to tilt it so that water will flow away from the mountain. Stick the popsicle sticks into the mountain on different sides and at different elevations. Only the top band, 1 centimeter of the sticks should be visible. Break sticks as required.
Sprinkle the mountain gently and steadily with a watering can so that rain falls straight down. This is a model of water erosion. How do the popsicle sticks show the erosion? Where is erosion most rapid? Where do the eroded particles go? Look for miniature streams, lakes, canyons, and landslides. The erosion of a pile of sand is based on the same principles as the erosion of exposed soil on hills and mountains.
Hello, my name is Will, and these people are Quentin, Emma, Michaela, Simon, and Eris. And we're going to tell you about how a rock is born in the form of a board game. This is how you play the game. 2 to 6 players can play at a time. All players start as an igneous rock. The point of the game is to go around the board in a counterclockwise direction and finish as an igneous rock. The dice shows the players the amount of spaces to move. If you land on sedimentary, metamorphic, or magma, you have to roll the dice again. If you roll a 1 or a 2, you have to follow the green arrow back to where you were. Wait until your next turn. P.S. When you're first leaving the igneous rock circle, there is no special roll required. But when you are finishing on the igneous rock circle, to finish the game, you need a special roll. To finish the game and get back to the igneous rock circle, you have to roll the exact number of spaces you are away from the igneous rock circle. The winner of the game is the person who makes it to to the igneous rock circle first and makes the final special throw. But if you roll a 1 or a 2 in the igneous rock circle, you have to follow the arrows back to where you were.
The arrow is pointing and that's the end of the game. There are 3 basic types of rocks. The rocks can turn into a different type of rock using time and condition. The igneous rock is formed by lots of heat and pressure in a volcano. Once the magma cools down, it forms a new rock. This rock is called igneous rock. Sedimentary rock is formed by the water breaking up into smaller bits of rock. This is called erosion. Some small rock fragments called sediments roll down from high places like hills. Then they are carried along by streams and rivers until they get to the ocean or low places on land. As more sediments are deposited over the years, the layers of the loose material become hard, then turn into rock. For example, sandstone consists of sand grains that have formed together. Metamorphic, also known as changed rocks, are also made from other rocks. With great amounts of heat and pressure, rocks can be folded, squeezed, and hardened into new rocks.
Hello, my name is scientist Elena.
Hi, my name is scientist Alex.
Today we are here to talk to you about what's inside the Earth.
The outside layer of the Earth is called the crust. We live on the crust.
The crust is the part of Earth that miners dig into and that caves are found in.
The crust is at most 70 kilometers thick. The crust is made out of 3 major kinds of ground: topsoil, subsoil, and bedrock.
Nobody has ever dug deeper than the Earth's crust. The deepest hole so far took 20 years to drill and is 12 kilometers thick.
Scientists have some clues about the mantle that lies below. Volcanic lava comes from the mantle.
Beneath the mantle is the core. The core has 2 parts, the inner core and the outer core. The inner core is a solid iron nickel ball, and the outer core is like thick pudding.
The deeper you go into the Earth, the hotter it gets. Scientists think the core is 6,000 degrees hot.
Hi, I'm Scientist Matt, and I'm here to talk to you about what's inside the Earth. As you can see, this might look like the Earth that we see from a radar. But when you flip it over, like when you cut it open, you would see this. The black represents the crust, the red represents the mantle, the yellow represents the outer core, and the white represents the inner core.
Hollow. And 2, the things that you need for this experiment is an apple right here and a knife that Mrs. Cochran is holding. Kids, do not try this at home. That's for 1. And 2, cut an apple in half vertically. Cut the apple in half again, but this time horizontally.
Examine the apple. Apples and the Earth have a lot in common. They are both round and solid. They are both surrounded by a very thin skin or crust. Look how thin the apple's skin is relative to the whole apple. Both an apple and the Earth have a core, and they both have a thick layer between the skin or crust and the core.
Look closely at the apple's core. You should see the seeds surrounded by a hollow space, which is surrounded by a harder shell. This is something like the Earth's inner and outer core. The Earth's inner core is solid, and its outer core is a thick liquid.